Hello everyone. In this video, we will try to understand programming of timer with the help of 8051. The simulation software which we are going to use is Keil Microvision C51. So we will try to understand how the timer is being placed in 8051. Along with that, how we can able to program the timer using Keil software. So while you are seeing the architecture of 8051, we can able to see two timers are being placed inside this chip itself, which is going to be called as timer 0 and timer 1. So with which we can able to make it use of these timers as timer or as well as counters. So the name which is given to the individual timer is going to be timer 0 and timer 1. So it is going to be given with the name of timer 0 and timer 1. So whatever register and other things we are going to use will be similar to the names given to those timers. So understanding the names of those timers is going to be important. So after moving from that one, what are the specifications of these timers? So in 8051, we are having two timers, which is called as timer 0 and timer 1. So they can be used as timers as well as they can be used as counters. Both timer 0 and timer 1 are 16-bit wide. So if it is going to be 16-bit wide, so the values of minimum is going to be 0, 0, 0, 0 and maximum is going to be FF, FF. Right? So I can able to count with these values. So the thing which you are going to use here in terms of 8086, it is comparatively a little different. So while you are going to see about 8086 architecture in our previous programs, so if you are going to give the value of 05, it is going to start counting from 05 and after that it is going to reduce to 02, after that it is going to reduce to 03, 02, 01 and it is going to stop its operation at 00. Right? That is what we have studied in terms of 8086. Here it is going to be a little different. So whatever we are value which we are going to give, assume that the value we are going to give is FF, F0. In terms of your count values, it is going to start counting with terms of FF, F1, FF, F2. All these things are going to be FF. So after that, it is going to count till FF, FF. So total here it is going to be 16 counts. So here we can able to give directly the count as 05 and it is going to start its count from 05 and it is going to reach 0 in terms of 8086. Here in terms of 8085, it is going to be little different. Sorry, 8051. It is going to be little different. So the value which are going to give, after that it is going to keep on increase its count and after that whenever it is going to find its FF, it is going to stop its timing or it stop its counting. So after that one, since 8051 follows 8-bit architecture, the 16-bit timer is going to be converted into two separate registers, which is called as lower byte and other one is going to be called as higher bytes. If it is going to be timer 0, the lower byte register is going to be called as TL0 and higher byte register is going to be called as TH0. So if you are going to give the value of FF, F0, so FF and F0, it is going to be moved into higher bytes TH0 and it is going to be moved into lower bytes TL0 because it can able to hold up to only 8 bits. But the timer is going to be 16 bits. So we need two different independent registers for counting 16-bit values. So these registers can be accessed like any other register. For example, if you are going to move the values of 4 to its count, I can able to move directly like this. Move instruction, I can able to move the value of 4 inside my TL0 as an example. So here in this example, if I want to make in terms of movement of F0 into TL0, so I can able to use the instruction move TL0, comma F0H. So if it is going to be alphabet, we have to add one more 0 to it. So it is going to be 0FH. I can able to move the values inside the register so that it can able to start its count from that values. So this is the general introduction for 8051 timer. So when you are going to see into what are the registers which is being used by your timer, so you can able to see your special function registers. In that, what are the registers which is going to be exactly used by your timers? So we are going to have in terms of your 8051, right? So in the same way, I can able to see the values. So here it is going to be TH0. So timer 0 higher bytes, timer 0 lower bytes, timer 1 higher bytes, timer 1 lower bytes. So it is going to be allocated to the specific memory location. So it is going to be 8C, it is going to be 8A, it is going to be 8D, and it is going to be 8B. So each and every byte we can able to see how it is going to be getting those values. So we can able to see while you are going inside program also. So how this memory address is being changed, because all these things are given with specific memory address. That is the advantage of 8051. So each and every register is given with an individual address. So I can able to directly give it as TH0, or I can able to give that memory location and I can able to give the values directly. So after that one, there are two different registers, which is going to be TMOD register and TCON register, which is going to be used by your 8051 for programming as well as controlling of your timers. So we will see all those things in detail while you are moving into programming. So what are the individual registers which is being used is going to be TMOD, TCON, TH0, TL0, TH1 and TL1. So these are going to be your individual registers which is being used by your timer. So after that, we can able to move inside your register memory location. So this TCON is going to get the value of 88, this TMOD is going to get the value of 89, and this TL0 is going to get the value of 8A, and TL1 is going to get the value of 8B, and TH0 is going to get the value of 8C, and TH1 is going to get the value of 8D. So these are the memory locations which is being provided for your timer registers. So all the things are going to be your 8-bit registers. So after that one, so we can able to understand what is TMOD register. So TMOD register is 8 bits. So the memory location which is provided is going to be in terms of 89. So this 89 value is given here. So what are the 8 values or memory locations which is going to be allocated for your TMOD register? First one, it is going to be gate for your timer 1, and next one is going to be whether it is going to be deciding whether it is going to be counter or timer, and next two things it is going to decide in which mode your timer is going to operate. Same thing for your timer 0 also. So while you are seeing about timers of 8086, we have understood what is gate. So again we will try to understand in terms of simple concept. So when your timer is set, which is going to be getting the value of 1, so what are the things it is going to check? So timer bar counter is enabled. So that specific timer bar counter is enabled if INT, interrupt pin, which is getting accessed by in terms of your pin diagram. So that pin should be high, and after that TR it is going to be used inside your TCON register. So we can able to understand that also what is TCON register. So with that TCON register, we can able to move the value of TR. So it is generally a small value. So we can able to see one by one how we are going to give it. So while you are using gate, so your interrupt pin should be high and your TR should be set, so that your counter or timer is going to be getting its operation. So when it is cleared, when you are having this TR bit of your TCON register is going to be set. So whenever it is going to be 0, it will work. At the time also it will work, but your counter bar timer is enabled only when your TR is going to be your condition. So here I am having two conditions. Here I am having only one condition if your gate is 0. So it is like an gateway to switch on your timer. So another gate is getting provided without an interrupt pin. So that is going to stop its operation. So whenever it is going to be cleared, whenever it is going to be 0, it is going to check the condition of only TR in my TCON register. Whenever it is going to be set, it is going to check for two different conditions. That's it. So while you are moving into C bar T, we are going to specify whether it is going to be operated as timer or counter. So whenever I am going to configure it as counter, so it is going to be set 1 because it is going to be counter bar timer hash whenever you are going to see the pin diagram. So whenever it is going to set the value, get the value of 1, it is going to be operated as counter. So this counter is getting enabled when you are going to get an input from TX pin inside your pin diagram or hardware. So whenever I am going to press the TX, that is going to give an input. It is going to count. So whenever it is set, it is going to operate as counter. So we are going to give the input with the help of my TX pin. So TX, it is going to vary from T1, T2, all those things. So whenever it is cleared, it is going to be operated. So this C bar T, whenever it is going to be 0, your timer is getting enabled. So whenever your timer is getting enabled, so you are going to get the input from your internal clock. This is what it means. After that one, so these are two different mode configuration bits. So how it is getting configured. So while you are seeing in terms of your timer 0, so at that time we can able to see, I can able to have in terms of modes. So here I can able to set in terms of 00 configuration, it is going to be 13-bit timer mode, so that it is going to get the maximum count of 1F. 13-bit, so which is going to be 1111, 1111. After that it is going to be 1111. After that one more 1 can be there, and after that other things are going to be 0, right, in terms of 16. So first 3 is going to be made as 0. So maximum count we can able to reach is going to be 1F. That is the count we can able to see with the help of this one. So yeah, I can make it. So after this one, if I am going to give in terms of mode 1, it is going to be configured as 16-bit counter or timer. Whenever it is going to be 10, it is going to be an auto reload option. As of now, in our program, we are not going to use this one, but while we are studying about theory, we will understand more about this one. So 1 is going to be split mode, in which TL0 is going to be acting as one timer and TH0 is going to be acting as one timer. So like this I can able to configure also. 2 8-bit timers, like that also I can able to configure. So as of now, in terms of programming, most of the cases we will try to use 16-bit timer mode only. So after that one, so main important thing, TMOD is not bit addressable, which means while in programming of 8051, we have understood like P set byte P1.3, which means port 1, third pin is getting set, right? So like programming like this is not possible in your TMOD. You have to give all the values, then only it can able to take. So, but your TCON register is a little bit different. So we can able to see that also. So this is going to give us gate. It is going to configure your timer or counter. So two different selections of your timer modes for configurations for timer 0 and timer 1. So next, your TCON register. TCON register is bit addressable. So what are the memory locations which is given for those individual bits? So we are having in terms of TF0. So we will see one by one. So what is TF, TR? So TR we have already seen in your previous slide itself, right? So we have seen like this has to be operated. This gate is going to be on when you are having your TR register is set, right? So like the same, that TR is going to be here inside your TCON register. So this is for your timer 1. TF is going to be for timer 1. TF0 is going to be for timer 0. And these are going to be your interrupts which is getting provided for your timer 0 and timer 1. So while you are doing programming in this session, we are not going to touch these things. But so TF1, it is going to be your overflow flag. So what it means, when you are going to have the count from F0 or FF0, and it is going to count till FF, right? After counting these values, so this TF1 is going to be set to 1. That is what it means. This is overflow flag. Whenever the count is getting completed, it is going to have the TF1 enabled, or it is going to be set. TR1, so this is like an power switch for your counter. Whenever it is TR1 is present, only at that time your counter or timer is going to be operated. Other than that, your timer and counter will not be operated. It is going to be in pass mode. So it is like an control bit. So it is going to decide whether the counter or timer has to be start or not. So it can be set or reset by using your program. So all other things are going to be your interrupt pins, which we are not going to touch now, but we will study in terms of theory, and we will in forthcoming classes we will try to understand all those things. So as a nutshell, We are having 4 different registers for storing the lower bytes and higher bytes of 2 timers. And after that, we are having TCON register, and after that, we are having TMOD register. All the things are going to be your 8-bit registers. So first problem. So find the timer clock frequency and its period for various 8051 based system with crystal frequency of 11.0592. So please make note of this one, because wherever you are going to use your 8051, we are going to use this crystal clock frequency of 11.0592 megahertz. So when the timer C bar T bit of your TMOD is going to be 0. So what is this TMOD C bar T is going to decide? So it is going to be acting as timer or counter. So whenever it is going to be 0, it is going to be your timer. Timer is getting enabled. So this sentence says that your timer is getting enabled and you are having the clock frequency of 11.0592. So after that one, you are trying to understand in what frequency timer clock frequency is going to be having. So in order to understand that, every time whenever you are going to have an oscillator, it is going to be divided by 12. So the crystal oscillator frequency is 11.0592, right? So if you are going to divide it by 12, so it is going to be kilohertz, sorry. So it is going to be 921.6 kilohertz, and your individual time period which you are going to have is going to be 1.085 microseconds, which means, so one complete cycle of your timer is going to be 1.085 microseconds, right? Please make note of these two things, which is going to be your clock frequency is going to be 11.0592 and your individual time period which is going to be taken by your timer circuit is going to be 1.085 microseconds. These two things are going to be most important things while you are moving inside your programming. So we are able to write a program. So write an 8051 assembly language programming. Create a square wave of 50% duty cycle. My first point, which is going to be having 50% duty cycle. That is my first point. So it is going to be having equal portions of high and low, because it is square, right? It is going to have equal portions of high and low. After that one, it is going to be reflecting, or it is going to be getting its output in the port 1.5. So port 1 and 5th pin. I have to get this square wave, and after that timer 0 has to be used. So timer to be used is going to be timer 0, and also calculate the delay generated as well as crystal oscillator frequency is going to be 11.0592. We have already seen these things, right? So 1.5 has to be taken, and after that timer 0 has to be used, and it should be having 50% duty cycle, which means if you are going to create a sine wave, it is going to be having 50% duty cycle. That is going to be freezed. So we can able to try to understand how we can able to write a program for this one. So first we have to decide what should be given in for your TMOD register, right? So it is going to be, I am preferable in terms of 16-bit counter or 16-bit timer. So if it is going to be 16-bit timer, so if you are going to take in terms of mode 0, so in that what we have understood, the thing is going to be in terms of your 15 bits only, right? So if I am going to take in terms of your values for 16 bit, it is going to be 13 bit, right? 13 bit. If it is going to be mode 0, it is 13 bit. If it is going to be mode 1, it is 16 bits. And if it is going to be mode 2, it is going to be auto reload. And if it is going to be mode 3, it is going to be your 2 individual timers. TL0 and TH0 are going to be your 2 individual timers. So I need this mode, because for counting it is more easy for me, because it is going to start its operation from one point. So I know that I am going to have this point somewhere. So after that one, I can able to count some maximum value is there, some values, and after that is going to count till FF, right? So it is easy for me to calculate my time period. So always I will prefer in terms of taking my mode 1. So I have given a condition, timer 0 should be used. So if it is going to be timer 0, it is the most important part which we have to think. So timer 1 is not being used here, make all things to be 0. And after that, if it is going to be timer 0, so gate is not needed. I am not going to trigger it from outside. So in software only I am going to give. And after that, I have to decide it is going to be CT, which is going to be 0, which is going to be for timer 0. So it should be 0 because it should be acting as a timer. And after that one, we are having M1 and M0. So in this category, I can able to see 0, 1 is going to be used. So if this 0, 1 is going to be used, correspondingly, it is going to be activated in mode 1, so that it is going to calculate its value from starting point to FF. So your overall output is going to be 0, 1, H. So timer 0 is getting selected and mode 1 is getting selected if I am going to give these values to TMOD register. Right? So after that one, we can get inside programming, core programming. So we know that TCON register is bit addressable. So that is not a problem. So I can directly use individual locations of my TCON register. Only TMOD is going to be my problem. So while moving these values, so first move the TMOD values with 0, 1, H. Sorry, H is missing here. So timer 0 and it is mode 1. Right? So if it is a square wave, so I have not given with what is the frequency of that square wave should be there. So I can able to take any values. It's not a problem for me. Depending upon that, your on and off time will vary. So if it is going to be on time and if it is going to be off time, so if I am going to calculate from here, this is going to be off time, it is going to be taken till here. So if I am going to change these values, it is going to have some higher values, and after that it is going to be lower values of equal width, right? So I can able to load any values. You can try with different values also. It is going to have 50% duty cycle because my programming is like that. So if it is going to be F, it is an alphabet, so 0 should be added in front. After that one, it is going to be getting its output in terms of port 1, 5th pin. So CPL, it is going to be used as complement. Complement, whenever it is going to have initially 0 and after that it is going to be toggled to 1. Whenever it is having 1, it is going to be toggled to 0. That is what it is going to do. Because in terms of square wave, it is going to be 0 and it is going to be 1. So it should be toggled between 0 and 1. So it should be toggled. So after that, A call delay. So why I am using A call delay? A call is going to act as an subroutine. So it is going to call an subroutine of some program. So it is going to have some program here. So after that, if this is going to be having at 2000H, this address is getting saved inside my stack. We have seen all these things in our theory class. So we will be moving this value into stack. It is going to execute it. Whenever it is finding return, it is going to jump back to the values by using push and pop, right? So push, it is going to push the value inside stack, and after that it is going to pop it out, and it is going to execute the values from 2000. So it is like an interrupt service routine. It is an interrupt service routine A call. So I have given the memory location as delay, right? So this delay is already here. So it is going to be suspending its operation from here and it is going to move here. Whenever it is going to find an return statement, it is going to jump back. So here we can able to see A call is there. So delay is being jumped. So in that specific point, I am saying that your T or not should be 0. Why I am using T or not? Because it is going to be timer 0. So it is like an power supply to your timer, right? So whenever it is there, it is going to be operated. That is what we have seen in terms of gate and other places also. So this is inside your TCON register. I should not push the values inside TCON register. It is not needed because it is bit addressable. So I can able to use this instruction itself. Else, if you are convenient in terms of using TCON register, you can do that also. That is also fine. So, but this is convenient for me, so I am using this one. So this is being executed, and after that one, it is going to take this value. So jump no byte TF naught. So it is going to be TF naught. What is TF naught? It is an overflow flag. Whenever it is getting completed, timer is getting completed, it is going to have its overflow. Till that time, it is going to have the value of 0. Sir. So I have to monitor whenever it is getting completed, right? So it is going to start its count from the value of 0F, FF and 0F2, F2. So FF, F2 is going to be the value, so that whenever the FF, FF value is got, so this TF naught is going to be having the value of 1. So whenever till I am having this value, which is going to be set to 1, I am going to repeat this loop again and again. Right? Why I am doing this one? Because I have to understand when this having an overflow. When it is having an overflow, I can able to say that this timer is completed its operation, it's completed its count, it can able to stop its final value. So I have to check for all the times. So till it's becoming 1, this loop will be executed again and again. So whenever it is identify this t of 0 is going to be 1, it is going to jump out of this one. So it's got the value of 1, right? So after that I have to clear my tr naught, and after that I have to clear my tf naught. Why I should clear my tr naught? Because tr naught is going to say that whether the timer has to be enabled or not, right? So I have to clear that one, and after that I have to clear my tf naught also, because it is getting the value of 1, because for next loop. So square wave should be continuous, right? So this should be continuous. Like this it should be there. So after completing this operation, it should come go to the next cycle, right? So if I want to take that, so this tr naught should be made 0 and tf naught should be made 0, and after that we can able to return the values. So I can able to return the value here. So I said that it is interrupt service routine, right? So it is going to jump back to ACALL again. So it is going to jump back here. So after that this instruction is getting executed. So yes, jump here, which is going to be jumping to that memory location without any condition, right? So that again the same pulse has to be generated. So it is going to be checking whether it is going to be completing its count or not. So all those things it is going to continue, repeat its operation again and again. So that first initially it will be having its 0, and after that it will be having its 1. So till 0 it's completed, right? So whenever it is going to complete its 0, after that we are making an again complement. So complement is going to take this one, and after that this is going to take this value, and like this it is going to be complementing those values, and we can able to get the values one by one. So in terms of complement, it depends upon your initial value. So you can able to first, you can clear your, if you want to be more clear in terms of where you want to that, so clear your P1.5. You can able to give this command also, so that it is going to start from 0, and after that one it is going to continue its operation. Like that I can able to do the programming whatever I want. So here the beauty of this one, so we can able to create an square wave. So whatever values we are going to give in terms of your count, depending upon the width will vary. Even though the width is varying, it is in square pulse. So always it is going to have 50% duty cycle. Whatever value you are going to put inside your TL naught and DH naught is not going to be a problem here. But in your next program, we are having an specification how to design this one. Okay. So with this one, if you are going to program it in this way, we can able to complete the square wave with the specification whatever we are being asked. So it is 50% duty cycle. So port 1.5 has to be accessed and timer 0 has to be given, right? This is what the program is. So with this one, I can able to move to my Keil programming. So I can directly use my Keil. Same program, I can able to load it here. And I can able to get the value. So already I have loaded that value. So TMOD is going to be 0, 1, timer 0, mode 1, all those things I have given. So how to open Keil and how to save the program and how to add file to source group, all those things I have made as a previous video. Just go through that video to create a new file and you can able to write your program, start writing your program there. As of now, I am just giving the program only. So while writing the program, we should be making clear like these things should be, origin should be there, and after that at last we should be having an end. So all other things you can able to comment and uncomment and you can use it. So the same program I have given here, and I can able to save it, and I can translate, build. After that rebuild, all the things I can able to give. So while you are doing this one, I should be giving the oscillator frequency. So you have to click this target, options for target. So while you are clicking these options for target, you will be having 11.0592. This crystal oscillator frequency should be given inside your target, else it will be having some other values. So please make sure that you are giving this crystal oscillator frequency. Okay. With this one you can able to make it as okay. So after that you can able to give this debug. Okay. So you can able to see one by one how it is being running. So in terms of peripherals, you can able to see your port. In that, port 1 is getting enabled, right? Port 1 fifth bit, fifth pin is going to be enabled. So I can able to take this port and I can able to see how it is getting varied. So my modifications will be in terms of 89H memory location, right? Because TCON, TMOD, TCON register, TCON register, TL, all those things are going to be located from the values of 8 something, right? So I am getting these things clear so that you can able to see if I am going to change a program here, correspondingly it is going to change its value. So one by one I can run it. So at that point of time, your TMOD is going to be getting the value of 1, 0, 1. So I can able to see 89 is getting the value of 0, 1. So even though I'm using it as TMOD, it is going to get the values at the value of 89H as T1, 0, 1. So after that one, I can able to give the value of F0, TL0. So F0 is being uploaded here. And after that, TH0 is going to get the value of FF. So it is getting the value of FF here. You can able to see your memory location, how it is getting varied. So after that one, we can able to see your complementing of your pin 1.5. So it is complemented, right? So it is complemented. Already it is 1, so that it is going to be make it as 0. Complementing operation is completed. So after that, a call delay. So it is going to be checking for delay. So I can able to run it and see at which time it is being your TR is going to be getting it 0, so that your timer is getting started, right? So after that one, till what time it should count. So that is going to be taken care by your jump statement. So it is going to be jump again. So whenever it is finding its value, it is going to be jump out of that one. So within that one, you can able to see TF0. So you are going to clear your TR0 and TF0, right? And after that, you can able to return to that value again in terms of a call. It is going to jump to the next statement of a call. So it is going to be jumping here. So while it is jumping here, you can able to move to that value and you can able to see it is going to be complementing to 1. So first pulse is getting completed, second pulse is going to be having the value of 1. First initially it is 0 and after that is 1. So it is difficult for us to view. So what we can do, we can run this program, and while you are doing your thing, there is a logic analysis window is there. You can click on it and you can able to see, and CRO kind of thing is appearing here. So if you are going to have the CRO kind of thing here, and after that go to setup. In that specifically, initially it will not be having any values. So press this insert button. So you know that it is P1.5, right? So just give capital P 1.5, right? And give this close. So that is getting configured. Port 1, 5th pin is getting configured. I can press my auto and I can see it is shifting, right? So after that, I can able to zoom in and zoom out to see how we are going to get those values. See here, I am getting a beautiful square wave. So with everyone will be getting different values depending upon your lower byte and higher byte values which you have given. So from that I have given a question, calculate the time period, right? So for the value of F2 to FF, what will be the value? In order to understand that, press this stop, and after that you can able to enable this cursor button. So you will be having a cursor. So you just place it at some origin point of this square wave, and after that you can able to see some point of this somewhere here. So while you are going to have a complete square wave, so we can able to see 69 microseconds is the square wave which is getting generated, right? So all these things are going to be toggling again and again, so that you can able to see all those values inside your toggling. So it is repeating its square wave, right? So it is going to toggle in those values. So how to fix the width of this square wave, we can able to see in the next program. That's it for this video. We can able to see the next things in forthcoming video. Thank you for your patient listening.